So we all know Netflix operates at a massive, massive scale. But what you might not know is how they just pulled off a huge speed boost for their databases. And the secret isn't what you think. It's not about throwing more expensive hardware at the problem. No, it's about a really smart architectural shift. And the results? They're pretty staggering.
And when I say staggering, I mean it. We're talking about a 75% increase in speed. 75%! That's a gigantic leap in performance. The kind of thing that has a real, tangible impact on millions of people trying to binge their favorite shows.
So, that's the big question, right? How on earth did one change in their database strategy unlock such a huge performance win? Well, the answer is surprisingly elegant, and it all comes down to something deep inside the system's memory architecture.
To really get why the solution is so brilliant, we first have to understand the problem they were facing. It all starts with Netflix's original setup, and a hidden bottleneck that was silently holding things back for years. For a long, long time, Netflix, like a ton of other companies, was running its own instances of Postgres on Amazon's EC2 servers. And look, on the surface, that's a totally standard, solid setup. But trying to manage that at Netflix's crazy scale, well, that came with some serious headaches.
Just imagine being on that team. You're handling everything by hand, manually scaling up for big movie premieres, pushing through super complex and risky upgrades, and just constantly worrying about fault tolerance. And of course, whenever there was a massive traffic spike, the whole system would start to slow down.
But here's the thing. All those operational headaches, they were just a symptom. The real bottleneck, the actual anchor dragging performance down, wasn't just the hassle of managing it all, it was something much deeper. A fundamental inefficiency in how standard Postgres handles memory.
Okay, so let's break this down. First up, you've got Postgres's own internal memory cache. It's called shared buffers. You can think of this as the database's own short-term memory, where it keeps all the data it thinks it's going to need again really soon.
But wait, that's not the only cache in the game. The server's operating system, well, it has its own separate memory cache called the OS page cache. And this is the real kicker. These two caches often end up holding duplicate copies of the exact same data. It's a huge waste of really valuable memory.
And this is where you can really see the inefficiency in action. When the database needs to grab some data, first it checks its own cache, the shared buffers. Miss. Okay, now it has to go check the second OS cache. Miss. Only after failing twice does it finally go to the slow physical disk. Each of those extra hops adds precious milliseconds of delay.
So, Netflix saw this whole 𝗂𝗂𝗁𝗃 mess and decided to make a big change. They migrated to Amazon Aurora, a database that was pretty much designed from the ground up to solve this exact problem by completely rethinking the whole memory architecture. Aurora's approach is kind of genius in its simplicity. It just gets rid of that redundant second OS page cache completely. It collapses two layers of memory management into one single, unified, and much smarter system. It's a total rethink of how a database should talk to the server's memory.
And because it eliminates that entire duplicate layer, Aurora can dedicate a huge chunk of the system's memory, we're talking about 75%, directly to its own shared buffer. This makes the database's main cache way, way bigger and way more effective, which means more of your data is just sitting there waiting in super fast memory.
So now, look at the new path to get data. It's just so much cleaner. With Aurora, the database checks its one single, massive shared buffer. If the data isn't there, boom, it goes straight to storage. That's it. No extra hops, no redundant checks. Just a clean, direct, and incredibly fast trip.
So we've gone through the how. Now for the fun part. What did this smart architectural shift actually mean for Netflix in the real world? Well, the results were nothing short of incredible.
And there's that magic number again. After they finished the migration, latency, the time it takes for the database to answer a request, plummeted by 75%. That directly translates to faster load times and a much smoother experience for you when you're hitting play.
And it wasn't just about speed. Because Aurora is a managed service, it handles all the annoying stuff like upgrades and fault tolerance automatically. This meant the cost for Netflix to manage their database fleet dropped by 28%. I mean, come on. It's faster and it's cheaper to run. That's the dream.
This quote from the team just perfectly captures the whole story. This wasn't just about swapping one piece of tech for another. It was about choosing a system that completely reimagined a core piece of how databases work. And boy, did it pay off.
And that really leaves us with a fascinating question to chew on. Seeing the huge gains Netflix got by challenging a long-held standard makes you wonder what other pieces of our everyday tech stack are just accepted as the way things are done and are just waiting for a similar, fundamental rethink.